So one of my favorite memories from exploring Nova Scotia as a kid was playing around in the tidal pools at the Fox Harbour beach and seeing all those little creepy crawlers and hermit crabs and different sea life within these little pools and along these shores was really interesting. So now that I'm a bit older and studying coastal life and studying biology, I thought I'd use one of my field assignments for intertidal ecology and diversity and dedicate that to exploring these shores again. So because Fox Harbour is such a lengthy area of shoreline, as the tide recedes, it results in pools of ocean water that collect and remain until the tide returns again. These tidal pools are small, shallow areas of seawater that are home to many flora and fauna that collect here. But the environmental conditions within these tidal pools range from the extremes. As they're exposed during the day, changes in oxygen level, salinity, and temperature can reach dangerous levels for most sea-dominant life. So what I want to do for this study is examine the different zones of the intertidal area, so the high shoreline further away from the open ocean to the mid shoreline, and then the lower shorelines closest to the open ocean or the low tide range, and see if there's any significant difference within the sea dominant life between these zones. What I expect to happen would be a larger number of sea dominant life closer to the lower shorelines, rather than the higher shorelines. What this could indicate would be a behavioral mechanism within these species that kind of avoid these harsh environmental conditions. So in particular, I'll look at the hermit crab species, and if I can't find enough hermit crabs within the tidal pools, I will expand this to any visible fauna. All right, so in about an hour, it'll be low tide. So I'm gonna start now on the higher shoreline tidal pools and work my way down towards the open ocean as the tide is receding. So I kind of have to work a bit backwards. I'm gonna start my measurements from the high tide, mid to low, and then from there, walk my way back to get the distance measurements, and hopefully I'll have pre-spaced it in my mind so I have it correctly. But for my distance measurements, I'll be using the Nike running app on my phone, which is fairly good at tracking distance, and from there I'll divide them into the 3 zones. And then since I'm only one person, I'll only do maybe 1 or 2 tide pools per section, and then manually count the number of hermit crabs or visible fauna that I can see. So I'm at Fox Harbour right now, and I definitely hit the jackpot. There's so many hermit crabs. Everywhere I go, there's at least 20 within my eyesight, so I've had to really reduce my sample area. So I changed the criteria to within my eyesight, because some of these tidal pools are quite large, so I definitely can't measure and count them all. So I'm just doing it within a 1 meter by 1 meter area around me, within my eyesight, counting how many hermit crabs I see there. Also, I'm only sampling the tidal pools that don't have any connecting source to the open ocean. So some of these have a little bit of rivers to them that connect to the ocean, and I'm just not going to count those. I'm only going to count the ones that are standing alone, the tidal pools that are standing alone. So this is just a quick summary of the raw data that was collected during my sampling. Samples were taken on August 20th, 2020 during low tide. And the distance between the high shore to the open ocean was about 330 meters. And the ranges of the high shore samples ranged from 0 to 110 meters. The mid-shoreline samples ranged from 110 to 230 meters. And the low shore samples ranged from 230 meters to 330 meters. For the high shoreline, the first tidal pool had a count of 20 hermit crabs. The second had a count of 10 hermit crabs. For the midshore, the first tidal pool had 18, where the second had 16. And for the low shore samples, the first tidal pool had 10 hermit crabs and the second had 6 hermit crabs. Okay, so already looking at my raw data, I know it's not what I expected, but still I conducted a one-way ANOVA testing of variance, assuming that all conditions were independent and not a normal distribution. And what this resulted in was a high F ratio of 11.167 and a p-value of 0.001. So my data shows significant difference between the conditions at a p-value less than 0.05, favoring the higher shorelines. So even though my results showed the opposite of what I expected, with more hermit crabs in the higher zone tidal pools rather than the lower zones, there was definitely a difference between the three zones. The higher tidal pools were loaded with hermit crabs of all sizes and shapes, and there were also clams, periwinkles, and a lot more sea-dominant life than I expected. Even with proper sample numbers, I would still expect to have similar results based on these observations. Now the tidal pools in the higher shoreline were large, definitely larger than the other two zones. And while I tried to accommodate this by limiting my count to a 1 meter range of eyesight, the environmental conditions in high or large tidal pools are much less extreme, which may have allowed for a higher abundancy of sea life. Now, if the distribution between the zones is completely random, this could have been a result of high energy currents or waves pushing the species into the grooves of sediment and trapping them there in the tidal pools as the tide recedes. But overall, I would love to see further studies on the hermit crab species of Fox Harbour. Their diversity and abundance is fascinating, and I still find them just as interesting as I did when I was a kid. And with such extreme conditions between the tidal pools, I think we should examine the distribution further within the different zones of tidal pools and the species that live here and assess their coping mechanisms to deal with these extreme conditions. And I hope you found this just as interesting as I did, and I'd love to hear your thoughts on the species distribution. Thank you.